Side-side angle triangles are pretty fun. These ambiguous cases. Are there no solutions? One solution, two solutions? Well, let us get some more examples with these kind of problems. All right. So, example 4. Solve the triangle or triangles with, and part A is going to say gamma is 85 degrees, B is 9, and C is 12. And again, if you want to, you could find the height and then use those definitions to figure out what case we're in. It depends on H, the height, and A. We don't have A here, but you could just draw a similar picture with different letters and check these as well. But my claim to you is that it doesn't. Well, where am I? Oh no. Pages got out of order. That's fine. My claim to you is that it doesn't matter whether you know where you're going. I mean, it's nicer to know where you're going, but I don't think it's worth the effort. So let's draw a picture. And again, our picture is just going to be maybe not for scale. Okay, so we're going to start with gamma. Gamma is an angle a little less than 90 degrees. That's 85 degrees. I'm going to try to make it bigger. I don't know what these angles are, so I'm just going to connect a triangle. This is gamma. B, it doesn't matter which one we call B. Let's call this beta and this alpha. So this is 9 over here. And C is opposite gamma with 12. We don't know A. We don't know alpha. We don't know beta. We're going to use the law of sines. Pick an angle and its opposite side pair that we know. I'm going to say the sine. Here, we'll leave a little room just in case we need to draw another triangle. The sine of 85 degrees divided by its opposite side length equals, we don't want to choose this pair because we don't know either one. We want to choose this pair because we know one of them. Equals the sine of beta divided by 9. Follow the steps to solve for the sine of beta. You should get that the sine of beta is equal to 9 times the sine of 85 degrees divided by 12. Now here's the real kicker. All right. What is our reference angle? Are there multiple answers? So beta, now maybe there's a beta prime, but beta is going to be the inverse sine of this. So beta is going to be the inverse sine, arc sine of 9 times the sine of 85 degrees. Make sure you're using degrees, divided by 12. And if you're using Google for this calculation, it's going to give you an answer in radians. So convert it to degrees. About 48.3438 degrees. I already forgot it. 48.3438 degrees. And now we have to ask ourselves 2 questions. Does beta prime make sense? Does it make sense that we have 2 triangles here? What would beta prime be? Well, just like in the last video, which is over here now, beta prime is going to be 180 degrees minus this other angle because of this picture, right? Beta is the reference angle, so beta prime is the second quadrant angle with the same reference angle. That's 180 degrees minus beta. So does beta prime, which would again be about 180 degrees minus this answer, 180 degrees minus this answer. This is what beta prime would be. 131, 65, 62. Does this make sense? Well, for it to make sense, I said there's two things that have to happen. The angles to the triangle have to add up to 180 degrees, and B prime has to be the biggest side. Into the angles, add to 180 degrees, and is B prime the biggest side? If both of these are true, then B prime makes sense, and we're going to have two triangles. One, that acute triangle like we have here, and the second will be an obtuse triangle like that. Well, let's check. Oh, wait a minute. If gamma is already 85, beta prime can't be this big. This doesn't make sense at all. Beta prime can't be so big. We're already over 180 degrees. Beta prime doesn't make sense at all. Oh. And is B prime the biggest side? Oh, check the number 2 thing. B prime has to be the biggest side for this to be the case. Is B prime the biggest side? I don't think so. B is 9. Does B prime make sense? There's only one triangle here. Woo! We like to see this. Okay, so we don't have to worry about solving two triangles. That's nice. So beta is 48.3 about. Like so. This is part of our answer. Let's keep on going. All that's left is alpha and A. So just like before, alpha is 180 degrees in a triangle. We know part of it is 85 degrees. And we know the other part is 48.3 about. What is that going to equal? Type a calculator. 46.7 approximately. That's our alpha. Or you can fill it in just like so. I already forgot it. 46.7. If you thought beta prime existed and you tried to find alpha prime, you'd get a negative number. All right, all that's left is using this 46.7. And again, it's best to use more digits. Like if you really wanted to be a mathematical superstar, you wouldn't say 46.7. You'd use 46.6562. You get a better answer, a more exact answer if you do this. But I'm not going to force you to use more decimals. You can even be a better mathematical superstar and use more digits, but that's fine. So again, we're going to use the same pair for the law of sines, 85 degrees and 12. Sine of 85 degrees over 12. But now, for the second pair, now we choose alpha, which we know, and A. Sine of alpha, 46, 65, 62. Make sure to include those degrees, otherwise it means something very different. Divided by A, which we don't know. Follow the exact same steps to solve this from before. You're going to get that A is 12 sine 46, 65, 62 degrees divided by the sine of 85 degrees. Plug this into a calculator and we're going to be done. All right. 12 times the sine of 46, 65, 62 degrees divided by the sine of 85 degrees. And A is about 8.8. It's approximately equal to 8.8. All right. There's only one triangle. Let's do our checks, our gut checks. Smallest angle, well, they're actually very close. Smallest angle, Smallest side, opposite. Biggest angle, opposite the biggest side. Woo! There we go. That's part A. Let's do part B. We'll be on the lookout. We'll be on the lookout for which case we're dealing with. We've seen 2 of the cases. There's 4 total. 2 of them are pretty similar though. In this triangle, one side, I'm not giving you names this time, one side has length 4 meters. And its opposite, an angle of 50 degrees. And a second side has length 10 meters. So again, we don't know what this triangle looks like. We're just going to draw an estimation. And it doesn't even give us the letters, so we're just going to name things whatever we want. I'm going to name it alpha, beta, gamma. You want to name it XYZ or JPB, whatever. Yeah, give the triangle my initials. That's supposed to be an A. So let's draw a little triangle. Let's say there's an angle of 50 degrees. Maybe that's this. Let's call that alpha. Why not? And its opposite, something of length 4 meters. And one of these other sides, we don't know which, it doesn't matter. 10 meters. This is going to be beta, this is going to be gamma, which means this has to be B. All right, so start with the law of sines. Pick a side with an opposite angle that we know. An angle and an opposite side, technically. Let's leave some space in case we need a second triangle. And then we're going to say the sine of alpha divided by A equals the sine of gamma over C. C is 10. Were there units in the last one? No, there weren't. All right. And again, follow the steps. You're going to get that sine of gamma is equal to 10 times the sine of 50 degrees divided by 4. All right, so gamma is going to be the arcsine of all of this. And then we'll check whether there's a gamma prime. Arcsine of 10 times the sine of 50 degrees divided by 4. Convert that into degrees, so times 180 divided by pi. Is Google failing me again? Maybe. It says it's undefined. Maybe it's undefined? Let's look at this. What are we taking the arcsine of? What is this thing right here? I'm trying to take the arcsine of this red thing is 1.9. When is the sine of gamma going to be 1.9? Oh, sine of gamma is never going to be 1.9. That's impossible. Sine, the range of sine is -1 to 1. Sine is the ratio of an opposite to a hypotenuse, and the hypotenuse is always the longest. The sine can never equal 1.9. There's no gamma that makes this true. There's no gamma that makes this true. So you wanted me to solve the triangle. Well, I wanted you to solve the triangle. I asked you to do something impossible. There's no solution here. There's no triangle. No triangle. It's impossible to draw a triangle with these descriptions. The side length isn't long enough. Okay? This 4 meters isn't long enough. And so if we look back at, I don't know where it is. Everything's all in the wrong spot here now. If we look back at those 3 triangles, it's this case. All right. The side link's not long enough. There's no angle that makes it work because the side can't reach. We're trying to build a triangle, but you gave me a really short piece of wood. All right, it's impossible. And it also, you can kind of see it in a different way. Remember that the biggest angle has to be opposite the biggest side. So gamma has to be really big, because 50 degrees was 4 meters. So 10 meters over here, gamma's gonna have to be pretty big. Another way of kind of seeing it, and like that kind of messes things up too. But yeah, there's no solution. You don't even have to know there's no solution, but as you're solving it, you get an undefined, you're gonna say, All right, so that's what this looks like. So between these two videos, we've seen 2 solutions, 1 solution, no solution. Learn how to identify each one. No solution means as we're solving, the gamma or the beta, the angle that we're solving for is undefined. That's that case where that side length's not long enough. Sometimes there's going to be 2 answers. So when we find that first angle, we have to look at the alternate version, the alternate reality, the dark version. Like you got like Jason as your like math professor, and then Jason Prime. Hopefully you don't ever meet Jason Prime. You have to say, does beta prime make sense? The angle that we solve is the one in the first quadrant. There's also one in the second quadrant with the same reference angle. So you calculate it by taking 180 degrees minus that beta. Okay. And does that make sense? Are there 2 solutions? To see whether beta prime makes sense, look at these 2 conditions. And in these videos, in the third video, we showed an occasion, this example. Example 3, where it did make sense, beta prime made sense, so we had 2 triangles. In the other example earlier in this video, 4a, we showed an example where beta prime didn't make sense, so beta prime doesn't exist. There's no second triangle in that one, in example 4a. And these 2 videos, examples 3 and examples 4, that's the tricky stuff for the law of sines. Everything else is more straightforward, but this is the stuff that is much more difficult. So please let me know if you have questions and reach out, all right? If you can do this, law of cosines is going to be a breeze. Anyway, let me know if you have questions, and I'm stumbling over my words. Bye-bye.